a wire of length 2.0 meters and diameter 0.80 millimeters is stretched by a force of 120 Newton and produces an extension of 1.2 millimeters. Calculate A. Tensile stress, B. Tensile strain, C. Young modulus of the wire. Okay, let's solve it. So we have our solution. So the length of the wire was 2.0 meters and the diameter, which is D, is 0.80 millimeters. So you have to convert this one to meters. So it will be 0.80 times 10 to the power minus 3 meters. Okay, and the force, which is F, was given to be 120 Newton, and also the extension, which is E, is 1.2 millimeters. So this will be equal to 1.2 times 10 to the power minus 3 meters. Okay, so before we proceed, we first need to calculate for the area of the wire. So area, which is A, the wire, will be equal to pi d squared over 2. Okay, so this will be equal to pi times the diameter squared. So diameter, we have it to be 0.80 times 10 to the power minus 3 all squared. Sorry, this one is 4 all over 4. So area will be equal to, by using our calculator, so pi times 0.80 times 10 to the power negative 3 to bracket all squared divided by 4. This will give us 5.03. Let me write it. So 5.03 times 10 to the power minus 7 meters squared. Okay, let's proceed. So we can now calculate for the tensile stress. So A, the formula for calculating for the tensile stress. So tensile stress is equal to force, which is F, over area, which is A. So tensile stress will be equal to, you have the force to be 120 divided by the area, which is 5.03 times 10 to the power minus 7. So therefore the tensile stress, let me write it here. Tensile stress by using calculator, 120 divided by 5.03 times 10 to the power minus 7. So this will give us 2.39 times 10 to the power 8 Newton per meter squared. Okay, so the unit for tensile stress is Newton per meter squared. Okay, let's move on to question B. Question B, we have to calculate for tensile strain. So tensile strain, the formula for calculating for tensile strain is extension, which is E, over original length of the wire. So we have extension to be 1.2 times 10 to the power minus 3 over the original length of the wire, which is 2.0. So therefore tensile strain will be equal to, let's use a calculator, so 1.2 times 10 to the power minus 3 divided by 2. This will give us 6.0 times 10 to the power minus 4. And tensile strain has no unit. Please don't forget. Okay, let's move on to question C. Question C, we have to calculate for Young modulus of the wire. As we have Young modulus, which is E, capital E, to be equal to tensile stress over tensile strain. Okay, so G, which is the Young modulus, will be equal to the tensile stress. We have it to be 2.39 times 10 to the power 8 all over tensile strain, which is 6.0 times 10 to the power minus 4. So Young modulus will be equal to, by using our calculator, 2.39 times 10 to the power 8 divided by 6 times 10 to the power 4. So this will give us 3.98 times 10 to the power 11 Newton per meter squared. So therefore, the tensile stress is 2.39 times 10 to the power 8 Newton per meter squared. And also the tensile strain is 6.0 times 10 to the power negative 4. And lastly, the Young modulus of the wire is 3.98 times 10 to the power 11 Newton per meter squared. Thank you very much. Please like, share, leave a comment, and also follow and subscribe for more. Bye bye.